Kia ora team. Today we're going to have a look at insulation resistance testing of an appliance in accordance with ASNZS3760. If you haven't already, what you want to do is go and have a look at my previous video on using the insulation resistance tester. That's going to give you some information about how we actually use the meter and the things that it does. And you'll need to know that stuff before we get into how to actually use it on an appliance. So I mentioned ASNZS3760, and that's where we find our testing procedure and the results that we need for this testing. And we have this up here, section 2.3.3.2, testing of insulation. What we're trying to achieve here is finding or ensuring that the live parts of our appliance that are supposed to be insulated from earth or any other conductors are in fact insulated from earth. So we're measuring the resistance, as the test says, measuring the resistance of the insulation between, for example, the phase wire and any earth part of the appliance. Or in fact, the neutral wire and any earth part of the appliance. So everything in that appliance that's supposed to be insulated from each other, that's what we're trying to test. Obviously, if there's any degradation of that insulation, any connections between, for example, phase and earth that aren't supposed to be there, that can cause a dangerous situation for us. If we, in fact, in our worst case scenario, the phase wire or a live conductor is touching the earth part of our appliance, then that makes that earth part of the appliance, the metal casing of the appliance, live, which would be a hazard to anybody who touches it. So that's what the insulation resistance test is for. Let's just have a look at that again. It says here, insulation shall be subject to a leakage current test or an insulation resistance test in accordance with Appendix E. Appendix E describes the process for doing the insulation resistance test, which I'm going to show you now. If you want to refer back to a written process for this, Appendix E is where you should go. It also says an earth leakage current test or an insulation resistance test. Earth leakage current test, it says, but it's got more information down here. If the appliance needs to be connected or live in order to be able to close any switches or utilize it properly, then we wouldn't be able to do an insulation resistance test because it would need to be dead to do that or unplugged. So we would do an earth current leakage test, which is measuring the current on the earth wire, which will tell us if there's any degradation of insulation between the phase and earth, obviously. We're not going to cover that today. It's very uncommon to do that, and if you do need to do it, well, the process is in Appendix E, but that would be in a more specialized situation. We're just covering the basic insulation resistance test that we do to test our appliances. As I've said in previous videos, this is about testing and tagging, what we commonly call testing and tagging. So this is the basic process of insulation resistance testing of appliances for our test and tag. If I scroll down here a little bit, we've got a table there for leakage current limits. Obviously, as I said, we're not going to look at that today. And we have table 2, insulation resistance limits. So this tells us the values that we need to find to ensure the test passes, or what the pass and fail values are. And it says here, class 1, that's the one that we're going to be dealing with today, a class 1 earthed appliance. A class 2 appliance is double insulated. We just need to test that there is no connection between live parts and accessible metal parts. So essentially the same test, and both of them are 1 megohm. We can see the M ohm symbol there. That means megohm, which is 1 million. So we're saying 1 million ohms. 1 million ohms between live parts. In this case, live means phase and neutral, and accessible earthed parts. So earthed parts should be our metal casing of our appliance. We should have already confirmed that our metal parts are correctly earthed doing our earth continuity test. And if you're unsure about that, pop back to my previous video on testing earth continuity for an appliance in accordance with ASNZS3760. Okay, so let's have a look at the test itself. So I have my appliance here. It's just a beat up old toaster. You can see plenty of metal on the outside. I used the same appliance for the earth continuity test video, and in fact in that video we did confirm that we had lower than 1 ohm earth continuity, so I can safely surmise that my earth pin and the entire metal case of this are all earth. So what I'm testing now is that there is no connection between the phase or the neutral pins and the earth pin or the appliance, so any earth part of the appliance. For this test, I'm going to use my insulation resistance tester. Again, there's another video talking about how to use this particular tester, so go back and watch that one if you're not sure. And otherwise, I'm going to crack straight into it. I'm going to select the 500 volt setting. We want to test with 500 volts DC, and I'll just do a quick prove to ensure that my meter is working. And I can also see then what the maximum values are on here. So I can see if I push this test button down, it says OL or overload, so that's off the scale. If I push the test button down and touch the leads together, you can see it goes very quickly to 0 ohms. So that's showing me that I've got 0 ohms with the leads together and essentially infinite ohms with the leads apart, which is exactly what I should be seeing. So the test process is very simple. For this particular meter, I'm going to need both hands to do this test, and the meter, I need to hold that test button down. There's 500 volts between those two probes there. Not enough energy in this circuit to be dangerous, but it will give me a little bite if I touch them. Hence the meter requires that I hold the button down. Because I'm going to need both hands, what I'm going to do first is hit the lock button and then push the test button. And that's going to hold the test on for me. So I'm going to start with the phase pin on my socket here, on my plug rather. And I test between there and the metal body. You can see I've still got overload. Now, one critical point that we need to touch on here is that I must put the switches on. I must test this with the switches on. If the switches are off, in this case the switches for the toaster are the pushing the toast button down. If I test with the switch is off, I'm only testing up to the switch. I'm not in fact testing the whole appliance. So all switch positions must be tested. So I hold that down on the phase pin and the earth, and you can see it shows up with a little bit of a reading and then very quickly goes back to OL. And if I push the other one down here, I've lost my connection on that pin there. We've got 3,403, so it's slowly rising, but we can see we have much greater than 1 mega ohm. In fact, we're looking at about 3,500 mega ohms or 3.5 billion ohms, which is plenty. So that's testing phase to earth with both switches on. We tested each switch individually. And just to confirm, I'm also going to do the same test with the neutral conductor. So I'll go to the neutral pin on my plug here, hold the switch down, touch to earth, and we can see it rises up to overload. And for the other set of elements, I push the other switch down, move out of the way so you can see the reading. There we go, and that rises up 3.4. We can actually see with both of those tests that in fact the insulation resistance on the second set of elements controlled by this switch is a little bit lower than this one. This one went to overload on both the phase and the neutral test, and then this one sat around 3,500 mega ohms, although that's still many times higher than what we need. I can also test, if I wanted to just test the integrity of the lead itself. As I said, to test the whole appliance, I need to push the switch down, and that will bring the element itself into the circuit. So if I were to measure phase to neutral with the switch on, that is with the switch pushed down, all I would be measuring then is the resistance of the element, because when the element is in the circuit, it's a resistance between phase and neutral. But I can, if I want to, this is not required, but you can see there I'm just between phase and neutral pins, and I'm getting a very high reading. If I push that down, that reading should go, I just need to unlock my meter, let's try that again. If I push it down, we should see that go to 0 or very low pretty quickly. There we go, because that's measuring the resistance of the element itself. But if I have the switch off, then I'm measuring the resistance between phase and neutral just in the lead up to the switch. And you can see there that I've got OL, so that tells me that the integrity of the insulation between phase and neutral up to the switch is also good. Well, that's it for this one. It's a pretty simple test again. All we need to do is test with 500 volts DC between our live parts, phase and neutral, and our earthed parts, the earth pin of the plug and or the physical body of the appliance itself, and ensure that the reading for all of those tests is above 1 megohm or 1 million ohms. Nice and easy. Thank you so much for your time. See you at the next one.